Hey guys, what's up? I'm Nalin Luthra, your robotics mentor, and we are back with cryptography 2. 2. Okay, so last time, let me just, I don't know. Yeah, so I installed the VS Code because some guys were saying we cannot see it properly in Nano. So I installed the VS Code to itself. I can just change the fonts and everything. I can do that, but maybe I don't know. So it's simple. Those who want to do it, you just have to go to where over here. So just go to like Google and type install VS Code on Kali. Click over here. It's good. Yeah, and we are good to go. Just write the command. So what the command is, it's quite simple. Just write this. Okay. Right, sudo app install whatever Kali like you got, right? So okay, so I'm just telling you guys that I installed the VS Code from the previous one because many people were complaining that you cannot use Nano properly. So I installed the VS Code. That's all. Okay, so it's not important, guys. So let's leave this one for first of all. Coming back to itself. So I guess everyone did saw yesterday's class and worked on Caesar cipher, right? Okay. All right. Give me a moment, guys. Yeah. So everyone worked with Caesar cipher, right? All right. Yeah. I don't know. This one. That's better. Yeah. So everyone did work with Caesar cipher and everything. So many people were complaining that they don't understand how to decipher it, right? Did everyone understand? No. Right? Did everyone understand that? I do need an answer for this one. If you don't, I will try to explain it again. Yeah, only 20 are watching. That's right. That's 20 are watching. I told you, like, everyone wants to do cybersecurity in the starting. Like, yeah, we would love to do cybersecurity. When actually things get a little bit difficult or a little boring, people quit. So I don't know if you guys want to do that. That's your wish, but that's how it goes. Cybersecurity is kind of a mixed field and everything. Right. So everyone did understand that why we're using n minus. Sorry, why we're using, what was it? It was like 26 minus n. Yeah, 26 minus n. That's why we're using this, right? So everyone did understand that, right? Okay, sounds good. So it looks good to me. Okay, now moving forward, I gave a homework to every one of you guys. The homework was quite simple. Okay, let me check that out as well for now. Homework was quite simple. I give everyone to that, like, that homework to you guys. So yeah, moving forward on that part. So our homework was that you need to tell me a method through which you can actually find a way to decode the ciphers, right? So how would you do that? Sure, Himanshu Patel. Let's shoot this. Go ahead, shoot it out. We'll see. We'll see. Yeah, come on. So let's have it out, guys. I don't know. Done. So yeah, many have done the homework. That's cool. I don't know. How should I answer that question? I have a good PC. That's good system. Good. I didn't give the question. I gave you to think. I don't know how many of you actually thought about it. So let's come to the point now. So how to actually decipher the Caesar cipher? That's the point. That's yeah. Himanshu, what didn't you exactly understand? Didn't you understand the decoding part or what one? Or and you're late, sorry. Okay, so decode minus thing. Oh yeah, so Sushant, I was talking about the point where how you actually decode the CS cipher, right? So use the same method as for the encryption. Encryption, right? Encryption. I have bad handwriting. Where you say you want to say a string, right, along with a key. That's what you give. So that's what you give. Just to change that part, you change your over here n. Okay, this is n, so it gets changed to 26 minus n, and this will use to be decipher. I explained this thing properly in the last lecture itself. So if you guys have not watched that, you should have. Okay, you're late over here. Yeah, that's how it is. That's how it is. Himanshu, can you please watch the previous video that will be fine because I explained properly over there because everyone did understood that. When I have not taught anything, I'm just explaining what I said in the last video because many people are saying that they don't understand why we're using 26 minus n. So we're using 26 minus n is because 26 is the number of alphabets we have, like so let's say letters. So it's kind of a simple thing that when you have these letters and you say let's say we have ABCD and that's just 4 letters we have. Let's imagine for a while that whole English is only based on 4 letters, A, B, C, D. That's all. Okay. Let's get bottom of the point and let's understand once and for all. Okay. Okay, code again. Okay, I will do that. Give me 5 minutes. Okay, so let's understand that. Well, let's imagine that whole English, what we have learned or whatever we know, is not there. Okay, let's say the whole English is only based on 4 letters. Okay, A, B, C, D. That's all. Whole English is based on 4 letters, A, B, C, D. Now, when I use a C cipher on this and say the value of n is 3, so what happens is I get something like this: A, because it's 3, so I will start from D, A, B, C, D, right? This is what I get from this if it's only based on 4 letters. Now, just imagine on this part that I completely switch it. Okay. Yeah, I did say that, and I'm going to start that just right now. Usually I've not done anything much. I'm just explaining what I explained yesterday. It's a small example. That's all. Don't worry, guys. Okay. So coming to this point is now that we have A, B, C, D. So imagine if we just got 4 letters in English. We have A, B, C, D. What we'll have, if say n is equal to 3, we will have B, C, D, right? Now, when we want to decrypt it, what you will do is you will just say, okay, we got 1, 2, 3, 4. Simple. Let's say 4 minus n. And over here is 3. So we say it's equal to 1. So now n is equal to 1 and rewrite it. So what happens if n is equal to 1? What we get? We get A, B, no, sorry, my bad. All right. Sorry. Yeah. What we get? So let n is equal to 1. We get over here. So for example, we want to code A, B, C, D itself. What do we get from this one? We get B, C, D. Right? This is what we get. Now I want again A, B, C, D back. Like this is what I want. So how do I pair it? I want B to be A, right? So what I do, kind of simple. N is equal to 1, right? So what I do, mosquitoes. Okay. So in this case, N is equal to 1. Yeah, that's a smart option. Thank you, Harsh. Thank you so much. Okay, so we have A, B, C, D, N is equal to 1, and what I do, I just want B to be A, right? That's how it is. So okay, A, B, C, D, and it works. That's all, right? So that's just reverse. N is equal to 1. Think cool. Okay, this is what I've done right over here. If you guys can see it, right? I said 26 minus n, right? And I did everything the same. It's working fine. That was supposed to work, right? Like that's what I'm doing. That's how decryption works, and that's how encryption is. Like I will just write it down over here as well. Encryption. Yeah. Cool. So let's rub it all together. Cool. Small. Cool. Yeah. We guess so. Yeah, we did. Okay, please zoom. Okay, I will zoom when I start the program. Now, the question is, what if you don't have the key? And what is the key over here? Key is the value of n which we require to actually decode the message. What if we don't have that key to actually decode it? Now that something comes over here interesting. The interesting part of the whole scenario is that when you want to actually decode the message, what you simply find all possible strings which can be made through that. And what are those possible strings? There are only 26 possible strings because that can be the value of n, right? Value of n can only be as big as 26, right? And we're good to go. So what I do is I will make a small loop for int. Okay, let's put up this one first of all. Cool. For int I is equal to 0. We say I is less than what? 26. Okay, let's say it's 1. That's fine. And we say I plus plus. That's all. And we use this I here as a key. And we are good to go. Right? That's right, one. N can be only as big as 26. So let's also say equal to over here. That will be much cool. Okay. What about special characters? That's right. But that depends on how we made the CS cipher. CS cipher was originally not made for the special characters to be taken into account. It was made for the Spring Boot strings. Also, we are not actually encoding those special characters. Let's look in the code back itself and understand that one. Okay, let's understand that one. Okay, let's understand that one for now. You see, I am not using that special code for encoding. If I do, I'm not changing the value of n, right? So it makes sense. What happens if I change the value of n? Let's say n is 27. In that case, we'll see what happens in that case too. Okay, so let's try it out. Let's code it. Let's understand it, and let's see how it goes. How big can we do it? Okay. So let's comment this code all together. I guess you guys can see the code if you're using a laptop. If you're using a phone to view it, maybe that's the problem that you were not able to see this. Okay, let me see if I can zoom it. Right. Okay, so let's start. Let's say I is equal to 0. Okay, and let's say while I is less than what? Let's say 26 for now. Okay, let's say print, okay, encrypt, and the message should be what? This is the message we are getting out of it, this one, right? So let's say this. Okay, let's copy this thing and let's paste it. Okay, and let's go with I. So that's what we're using over here, right? Over here I'm using 3 and over here I'm using this. Okay, so let's have one more command, print, like this. Like, do I print ln in Python? So yeah, I don't think we need this one as well. Let's see what we get. Let's run the code. Let me save it. Let's say python.py. Okay, that's weird. Sorry, I also supposed to be doing I is equal to I plus 1. Yeah, makes sense. My bad. Yeah. It won't hang on my system. I'm pretty sure about that, but yeah, I did a mistake. Okay, so this is what I get. I get all the possible combinations for this, right? I get this, everything. So what exactly do I need? So I need to check this is the answer, right? Okay, so I can zoom. Can I zoom this one? I don't know I can zoom this one or not. Okay, let me see how can I zoom. Is it good, guys? Can you see now? Right, maybe this is better now. So yeah, you can see I can definitely find the answer right over here. Oh yeah, it's getting slow somehow. Okay, my system is getting slow. Weird enough. Cool, got it. Now you can see we get coding blocks directly. So what if I just say, okay, let's print what? Let's say plus this plus I. Let's do that as well. Okay, let's print this thing again and see what we get. Somehow it doesn't work with this. Okay, let's str. Let's have str now. Cool. Okay, cool. So we got 23 right over here. We get okay. I should think control plus plus. I'm doing okay. Yeah, control plus plus sounds good. Thanks, Aryan. Control plus plus looks good. Yeah, is it good now? Oh, it's weird for me now, but it looks fine for you guys. So let me just say it like switch for screen. Cool. Right? You guys can see this now clearly and properly. Cool. Okay, so this is how you can simply do it. For example, let's take one more example. Let's say value is 27. Now that's more than 26. So what would happen? You see, coding box still comes. What if value is 30? Right? Let's go with 30 now. And let's start. Where is coding box? It should be somewhere there. It should be. I don't know. Should be here or should not be here? That's the question now. I cannot see it. Okay, yeah, 22. Here it is. Right? Every time you try it out, it works. It doesn't matter what's the value of n. Even if n was way too high, it will be here. Let's go with a bigger number for now. Let's go with 100. Let's take 100 and check it out. Cool. Now even I don't know where it is. I've taken a really big number. I hope I'm not wrong. Yeah, I'm not wrong. I'm a genius somehow. Why am I? I'm not. Everyone knows what this. So, okay. So we got this, right? So we got on 4. So that's how you actually crack a serious cipher. So now, wherever you see a serious cipher, you can guess what word should be there, and it will happen. That's right, it will start repeating itself because it's a rotational serious cipher. That's how it rotates. Okay, so I don't know Python. That's why I can't able to understand what to do. Python is kind of a simple. Okay, so what I'm doing here is just using words, right? So let's say while basically means a loop. So if you're familiar with C++, that's a while. If you're familiar with what language? Let's take a language for now. What language is similar with? If Java, it should be int I and so on, right? So either ways, it's fine. It's fine. So that's how it goes. Okay. If you got a doubt, just message the doubt in the chat. Don't say doubt. Like that's weird. I don't know what doubt you have. If you tell me the doubt, I will give you the answer, right? Java, it's fine. That's same. I think this code will work. Anything you have to change in Java is like this. So you will just like system.out.print. That's what you do in Java. Okay, and you here you will write int. Yeah, it's a Java code now. Okay, so this code will work in Java. That's all. That's simple. Okay. Okay, coming back to this. Here it is back. Okay, it is not happening. What is not happening? I don't know. It's working fine actually. You can see this code. It's working fine. See, this is how it is. It is working fine. If you guys want the code, I will give you the code. That's not a problem. But I'm pretty sure it's working fine. I know it's working fine because it's working right now. Okay, so I don't know what's not happening. Okay, JavaScript. Yeah, JavaScript is cool. Yeah, I will use JavaScript as well. Like, what do you want me to do? Do you want me? Yeah, that would be a syntax error. You have to write this now. Okay. That's fine usually. You're checking me. I don't know stuff or what? Like that's fine. This is more of a logic building, right? It's not about coding. I have no idea, Manshu. What are you saying? What's not typing and what's not getting it done? I don't know, man. So I can't actually answer everything. Okay, guys, sorry. Let's move forward, guys. Let's move forward to that set. Okay, now today we'll look at one more cipher. We are good with CS cipher now, right? Everyone is good with CS cipher. We have the code. We made a code of our own, and we're good with it. There is no JavaScript. There is JavaScript, first of all, guys. That's how it is. Okay, anyhow, let's move forward and work towards a new cipher, which is called a substitution cipher, a mono substitution cipher. Let's see how it works. Oh, no. Okay, here we are. Now let's talk about mono substitution cipher. Let's have a get to next language. Work on. Alexa, drum roll please.
Sorry, मुझे ये नहीं पता.
Alexa, drum roll please.
Okay.
Cool. So let's go with next cipher with us. That's mono substitution cipher. Okay, let's.
Amazon Music पर
Alexa,
ये रहा
stop.
प्रदीप कुमार का दलाल.
Stop. Thank you. Sorry. Mono substitution cipher. Okay, I got messages, guys. I don't know what you guys have. Okay, yeah, cool. So let's say mono substitution cipher. Yeah. Okay. Okay. I will try to speak slowly. You know, Alexa is OP, right? Happens a lot of times with me. Okay. Alexa gone wrong. That's why. Okay, so let's speak slowly now for a while. Okay, guys. Let's get to a point now. What is mono substitution cipher? So today we have, okay, not today. Yesterday we have talked about with cipher. We talked about Caesar cipher. Now, what exactly is mono substitution? So what happens in case of mono substitution is we don't have a proper rotation, right? So in case of Caesar, we used to have a rotation, right? So for example, start from A, B, C. Let me just put this down. Okay, so we have this, right? So that's how you map together things, right? So this thing just map like this, it's map like this, and so on. Okay, that's how it goes. But in case of mono substitution, that's how it works. So what happens in case of mono substitution? Let's look at that for a while. Okay, let's rub it off. Yeah, cool. So in case of mono substitution cipher, what works exactly and how it moves forward is we map things randomly, right? So there is nothing as a proper way to get it done. It's completely random. For example, let's say A is mapped with C, and D is mapped with A, and E is mapped with K, and K is mapped with what, D? No, yeah, D sounds good. And L is mapped with I, or whatever you want. Okay, so that's extremely and completely random. Okay, so that's how you work with a mono substitution cipher. You make completely random things you want to, right? So that's how it works. Is everyone good with it? Is everyone good with, like, did everyone understand what is mono substitution? We change things randomly one by one. We change this, we change that, here, there, and everywhere, right? Okay, did everyone got it? Like, what is mono substitution? Mono substitution basically means mono means one. Substitution means change. So mono substitution means changing one, right? Not really part. If you don't know the algorithms, you won't be able to decode it. So yeah, it's kind of like slightly different. Because we know the key, right? So what happens is, you know a key. In case of Caesar cipher, we can actually guess a key because key is supposed to be limited range, right? Yeah, cool. It got it wrong. Some time it doesn't work. Okay, so key in case of Caesar cipher, key was in range from 0 to n, and n over here is 26, right? Okay, wait guys, wait. हिंदी में एक्सप्लेन करते हैं एक बार, समझो मैं क्या कह रहा हूं कि मैंने A को C में चेंज करा, राइट, और D को A में, E को K में, K को D में, L को I में. मैं रैंडमली 26 अल्फाबेट्स यहां लूंगा, 26 अल्फाबेट्स यहां लूंगा, और उसको जैसे वो ऊपर नीचे चेंज करता हूं. Completely random, and that depends on me how I want to do it, right? It's random. But ये जो मैं कर रहा हूं चीज, ये पूरी की पूरी, ये एक की है. Are you getting it? So सीजर साइफर के केस में कितनी कीज पॉसिबल थी? 0 to 26. बट इसके केस में कितनी की पॉसिबल है? जितनी मर्जी, राइट? Like not जितनी मर्जी, actually it's like 26 into 26. That's the answer. That's how many keys. Am I right? If I'm wrong, let me know. Like, I don't know. If I want to pair 26 alphabets with 26 other alphabets, how many possible scenarios are there? That's simple, like 2 change 6 raised to 2. Right? That's what I think. Believing that everyone has to have one. Oh, I'm wrong. I don't know. Maybe I'm wrong with probabilities. I don't know. I have to check it out. But I think it will work. Yeah, but the point is it's a big number. That's the whole point, right? No. 26 are not there. It's more than 26. Because let's say A. Okay, let's talk about A. So A can be linked with B, C, D, E, F, G, anything from 26. Right? A can be linked with anything from 26. Let's talk about B. So B can only be linked with numbers which are not there, right? Maybe I'm wrong with 26 and 26. That's not the right answer. Maybe I'm wrong. I don't know. I'm not sure about that, but it's a big number. Let's say N is a big number and it's not easy to crack. So let's talk about B now. So B can be linked with what? Anything except for 26. So B got like 25. C got like 24 and so on. So we would have 26 into 25 into 24 and so on. Like that's how it's. Okay, so my answer is wrong. So you have how many keys for this one? I told you how many keys are there. It's sort of simple. We have what? Like 26 minus 25 into 24 into 23 into 22 into 21 into 20 into 19 and so on up till 1. Yeah, that's how it is. So it's like, okay, let's make it right. 26 factorial. These many keys might be required, right? Yeah. So that's how it's working, right? So maybe I'm wrong, I don't know. But point is, it got many keys, and that's how it works. Okay, that's my point I want to make. I don't want to make a point. Like I know the answers. I'm not good with maths. I'm great with maths. I don't know. But yeah, it's a good point. It's a good thing. We got many keys altogether, and we won't do it. So in that case, n becomes large, and it's become difficult for anyone to crack the key altogether. Am I right or am I right? I'm right. Okay, so Amit Sharma has the answer over here. I'm not sure it's right or wrong, but someone has the answer over here. Maybe it's right, maybe it's wrong. People like calculator Sharma again. So yeah, so we got big numbers over here, right? So so that's the point. So let's move forward and let's write the code for substitution cipher. Okay, that's weird. I think I should have a voiceover like thing, right? Like substitutions, like mono substitution cipher, doom 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 boom. Yeah, that would be cool. I'll figure it out somewhere, right? I'm like, cool. Okay. I don't know. Okay, people are like fighting over this. Kaun Sharma gaya, kya Sharma gaya, and whatever not. You want to see? Let's do it. What I'm doing here, I'm not doing it over here. I'll write a code for it if I want to. I can write a code for it. Okay, guys, so let's move forward and work with mono substitution. Mono sub. Okay, let's first save this file first of all. Okay, let's call it mono.py. Cool. Mono substitution. Let's work with that one now. I got many messages. Yeah, that's right, Sushant. I can make a little track for something like something like this, right? That would be cool. Okay, anyhow, until unless we make that track, let's just say doom 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 doom. Sorry. Okay, let's say we're on substitution. Substitution. Cool. I'm bad with French spellings. I'm bad with maths. I don't know what I'm good with. Sometimes I feel like what's happening around the world. Weird points. Now let's move forward. Mono substitution. Okay. Yeah, that's right. So, okay, well, why are we having a discussion on what's right and what's wrong in this case? Let's move forward and write the code itself, guys. That would be cooler and nice and fast and better way to actually learn things. So, first of all, let's make a key. Okay, I did make a key previously. Let's make a key first of all. So key is equal to, so it's not typing, actually it should have been typed over here. Okay, I got something over here. Yeah, good. Things are set now. Let's go. So key is equal to, let's start the key. Let's start with A, right? Okay, let's start with A. Okay, let's say with Z. Okay, let's start with B. This is so boring, man. I was like, took me a day over, like, seriously, that's a very long time to get it done. Let's go with C. I don't know. It's weird. Should I do this one? Should I write a code for generate a key or something like that? That's a weird way to do it. What took me so much time to actually get this thing done? It's like A, B, like. Hey, Ariman. Shutter, what's up? Like, hey. Okay, my spelling is wrong. Should be like this. Substitution. Yeah. Okay, cool. Right, so let's move forward now. Actually, it will take me a day time to actually make the key. So I will just copy a key I already have. I have made a code previously. Let me find this one, and yeah, let's go. Okay, so let's say like this. Cool. I have key already with me. Let's take this one. Okay, I will share the key with you guys. That's fine. I already made this key. Let's get this thing done. So I have a key with me now. Okay, so it's fine. Like you just have to make a key and like just copy this key or make your own. I don't know, whatever you want to do. You just have to map things one to one. So that's a dictionary, right? This is a dictionary. Those who don't know Python, I should tell them this is a dictionary. Okay, so this is a dictionary, and that's how it works. Right. So let me send you the code itself as well. Okay. Yeah, I'm just sending the code in case someone wants it. Cool. Code send in chat, guys. So if you want, you can get the code from the chat itself. This is a key which I made. Take it and let's practice with this one. Okay. Now let's write the code for encoding. That would be cool. Okay, let's go down, 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 down. Somehow it's not working that good in Kali. I think I should code in my normal Windows, but whatever. Let's do it. So let's say mono encode. Okay. That's how we get. We will give a key to it. That's important, and we also give a plain text. That's important, right? Let's move forward now. We got plain text and everything. So let's say plain text is equal to plain text dot lower. That's important because I will make everything lower. I don't want to get the complexity of handling upper cases and lower cases separately. Let's go and lower itself. Okay, now let's talk about ciphertext. Okay, so let's say ciphertext is equal to nothing because that's what we have to generate now. Okay, so let's say for I in range. Anyone got any doubts in the till now? I don't think so. Okay, let's say for I in plain text, not instead of range. Let's go with plain text, and let's say that ciphertext is equal to ciphertext plus plain text I over here. That's right. And we'll return what? Ciphertext. So what will this function do? Simple. This function will allow us to make cipher text. Cool. Let's move forward now. Okay, I will create an account. I will do what it asks me to do. Okay, let's move forward. Now, let's say def. Now let's make something for decoding as well. Okay, so let's say flex mono decode. Right, mono decode. Right, so let's go mono decode. Let's call about like ciphertext is equal to what? Ciphertext dot lower. Okay, what variable should I pass in case of decode? Like I should give key. That's important, right? Key is important. Key is like super important. I think I'm getting something wrong where it should be key over there as well, because as you can see, I'm using plain text. It should be key because that's what I'm using, right? So I'm basically mapping things. That's why I should be using key over here, right? Cool. So we call what ciphertext now, right? So ciphertext. Now what should we do? We have ciphertext. What should we do? We should make a plain text, right? We call it plain text and good. We should also have ciphertext over here. So let's have ciphertext. We've got plain text, ciphertext, whatever text we got. Okay. Really? I don't know how to mute my keyboard. Like, if I just type slowly, it would mute my keyboard. That would be weird. I can do that, but that would be weird. Okay. So now let's move forward, guys. So let's have okay. Now we have what we have to do is we basically have to reverse the key, right? What we have to do is we have to reverse our dictionary. So what dictionary we made? Let's move this one. Okay, we made this dictionary, right, guys? We have to reverse it now. I have to say that this should come here and this should come here. There's two ways to do it. Point number one. One way is to actually just copy this key, copy it, make a new one over here. Okay, copy this thing whole, write it over here, delete it from here, and call it decode key. That's one way to do it, and it will work fine. And I can just simply use the same mono encode method and with this decode key, and it will work fabulously. We don't have to actually write a mono decode method altogether, but that's a vague way to do it. Okay, we should not have two different keys because if we can work on one single key, why do we need two different keys? That would be a stupid way. So if anyone comes up with that way, it would be weird. Okay, so what I'll do is I will make another code for it. So let's have keys. Okay, so let's have list of, let's make list key. Okay, that should be let's make a list altogether. List. Okay, we have key dot keys. Okay, let me, those who don't know Python, again I should tell them this keys will give me all the values of the dictionary, right? Okay, so no, not the values. I'm sorry. These will give me all the keys of dictionary. Now we have list values, right? So let's call it list values. We say list. Okay. Now let's say key dot values, and I will have all the values with me, right? So this will, let's copy this one over here, paste it over here. Okay, let's close it. Yeah, let's paste it over here. Okay, I should just call it over here like values. Cool. I don't know, some people messaging me, I don't know what to tell them. I don't know. Okay, let's say for I in ciphertext, because that's how we want to change it, like ciphertext, right? So forward, we say plain text is equal to plain text plus, you can also just shortcut over here. Let's use a shortcut now. So you should know how you should actually write codes. Don't be a noob, use shortcuts. Okay, what's this? What do I do? You should never be late, man. Come on, be on time. Okay, now say plain text. Okay, let's have list key. With list key, I have list values. With that, I should say index. And I should say I. And it's done. Hopefully, I don't know. We'll see. Return plain text. I think it will work. I'm not sure because I just written a code altogether. Let's see if it works or not. I don't know. My code never works on first time. We will see. Okay. So you have mono encode, we have mono decode and everything. Okay. I think it's good. It's good, right? Everyone understand this one? It's good. It looks good to me. Okay. So let's write something and encode it. Okay. So let's say mono code. Let's mono encode. Let's send the key. And what should we encode? We should encode. Okay. I think key is this one. This key is right. I don't know. We are using capital key or small key. Okay. Not small. Okay. Overhead small too. Yeah. Cool. Okay. So now let's encode Nalin. Luthra. Let's encode this. Cool. Let's encode Nalin Luthra. How to do it now? Let's run new terminal. Let's say Python mono.py. Okay, it's not here. I should go cd desktop / cryptography maybe. Yeah. Now it's a Python mono.py. Yeah, told you. My code never works on first time. Yeah, my bad. This should not be there. See, never ever. Anyhow. Okay, let's say mono.py. What we got? We got nothing. Okay, because I didn't print it. I should print it. Let's say print, right? Actually, I'm using Python 2 over here, so it will work like this. If you're using Python 3, you just write this. That's all. Okay, this is fine. So I will say like Python 3 mono.py. Yeah, see, it works fine. So either way, this should be fine. Okay. Now let's say how to decode it. Okay, let's copy this thing over here. From here. Wow. Copy. Cool. Let's comment this one. Right. Let's say print mono decode. Right. We'll call it key. Okay. Let's save this one. Let's run Python mono.py. Done it. Awesome. Code worked in first time. Awesome, man. So we did the mono substitution right now. I got some doubts. So many people are going to say this, I don't know. How do you manage so many languages? It's that simple. You practice those languages a lot, so you get habitual with these languages. So you're good with it. So I know Java, Python, C++, Python 3, that's same. Python 3 is same. Just a little bit of differences. JavaScript, TypeScript, that's cool. JavaScript, TypeScript is actually same. When you know many languages, you just get hang of it, and you know like everything is kind of the same in many languages. Like in case of C and C++, like in case of C++, things are same. In case of Java and C++, things are same again. Only like a little bit of differences, just like print out statements and all stuff like that. Then again comes Arduino, which is similar to C++ and Java together because it uses print a lot. Processing also works in similar ways on Java. I don't know what other languages are like. Golang is cool. Swift works the same as Python, so that's how you can relate it. What about like so Perl is a difficult one. Bash is the same as Perl, so we can actually get hang of it. So let's not get into that. So yeah, you learn many languages and you get it done. So please code explain once again. So yeah, let's explain the code once again. Okay, so this is the dictionary I made. Okay, guys, so how you made a dictionary is kind of simple. Let me tell you how I made it. I made dictionary previously for the code itself, so I don't have to waste my time and stuff like that. Okay, so in that case, it's simple. Let's say A, B, C, D, E, F, G, H. So you write everything you want in paper. After that, you just say A is equal to B. So just cut the B. Now B is equal to C. Now cut the C. C is equal to D. Now cut D from here, right? So like maybe let's say C is equal to E. Okay. So now you cut the E and so on. So that's how you do it on paper. Okay. D. Cool. So okay, that's how you do it. And you do this for all the 26 alphabets. These alphabets should go in ABC format, and you just cut those from here, like this. Okay, so that's where you won't be able to what do you call it? Miss any letters in throughout the scenario. Okay, so let's get back to it. So that's how I do it. So I take A, I take Z, so I cut the Z. Now I've written ABCD over here like this. Okay, and after that I wrote those random things which I was left, and I just cut this from the paper, and that's how you get it done. After that, from here I use mono encode. Okay, I pass a key. Which is the key? This is the key. Okay, this is the key which I made. I will going to pass this in a function. This is the function I've made. I'm sending a plain text. Okay, so let's see what the plain text I've sent. I've sent plain text over here as Nalin Luthra, right? So I text the plain text. I make it lower. So when I'm using something as capital N over here, right? So over here it will become lower on its own. Again comes the cipher text. So I've made a simple plain cipher text, right? So that's right, Vidasha. That's right. That's how I'm doing that. Okay, for now I in plain text. So like I goes in plain text, we get it key. What is the key over here? This is the key. So whatever I have over here is like this. So do I have my pen with me? Oh, let me get a pen. Oh, not this one. Let me have a pen. Cool. Coming. Here. My pen is here. No, I don't want to download it. Okay, let's move forward. Cool. Yeah. So you see your key over here. So when I open this one, I will get say like key. I give A, right? So I instantly get a Z, right? That's how it's working over here. This thing. That's how dictionary works in Python. Okay, guys. That's how I'm getting it done. Moving forward to this one. Our system is okay. Sorry. Yeah, that's better. Cool. So that's how I get it done. You know what? I don't know. I can leave it. I'll tell you something. A problem I have with Kali. Kali is weird. Now I just return the cipher text altogether, and I use mono decode over here, and I use the cipher text, lot lower, list, and whatnot. Okay, that's how you get it done. It's done. So up till now, we have used two different ciphers on Saturdays and Sundays. On Saturday, we talked about encryption and everything, and we talk about Caesar cipher. On Sunday, today itself, we talk about which cipher. This is a mono substitution cipher. All these cipher worked by replacing only one alphabet altogether. I can also decode this cipher if I use like 26 factorial, right? So 26 factorial. How big is 26 factorial? Let's I should write a code on something like that. I don't know. You just figure it out. So we can actually decode even mono substitution as well. It won't be that difficult. How you do it? It's kind of a simple. You just need how many? Like 26 different loops. So I'm just like let's think about this. Okay, so let me give you a sample code, and that's your homework. Your homework is to write a code to actually decode mono substitution. Okay, you have to print all the digits which are there, and then you have to find a key out of it and decode it. Right? I know it could be difficult, but what if, let's say, you got a paper, right? On that paper itself, you know that Zekruk means Nalin, and that's the only thing you know, and you don't know anything else. You just know Zekruk means Nalin. Using this, you can actually decode it easily. No Lakshay. That's not a 2D loop. That would be 26 loop, 26D loop. That's weird. Okay. Devanshu, what's factorial? Devanshu factorial means if I say 26 factorial, it's mean 26, 25, 24, 23, 23, 22, 21, and so like 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. Right? 5 factorial means 5 into 4 into 3 into 2, 1. So 5 into 4, 20, 20 into 3, 60, 60 into 2, 120. So 5 factorial is 120. 6 factorial is 720. 7 factorial, I don't know. I'm not that genius, and so on. So now you guys have to think, how would you decode it when you know Kazrak means Nalin and you don't have this key with you? This key with you don't have it. You just know Krezek means Nalin, and then you have to figure out what does Ruzziad means. Right? You can guess these things, but I don't know. So now you have to do it. You have to figure it out. That's your homework. Think harder. I give a good example how to do it. I will just write a one more code how to do it. I will just say for I in range 26. That's all. And I will make one loop. Let's say A is equal to A, B, Okay, like these are letters over here. I'm just giving you a hint. You have to think, guys. Okay, this is not the right answer. I'm just giving you a hint. Use this for I. Now use this for J. K, L, and so on. This list will go up to 26. You can easily check it, like if that matches this one or not. That's one way. Or maybe you can decrease it a bit. How about taking 25? Because no, when you have the 26 one, you don't actually need this one. I don't know. Maybe that could be the answer for you guys. Think about it. How would you actually decipher this one without having the key? You only know Nalin means Krizek, and that's all. Now think hard and decipher it. Okay. What you guys use, that's completely on you. On the next class, we will go one step higher. Instead of going with one substitution, we'll take 2 letters and do substitution, which is a Playfair cipher. Okay, I should not tell you that one because that's a surprise, but whatever. Okay, guys, so we will do a different cryptography on the next class itself. So best of luck. And do not forget to decode this. If you want, I can send the code. I will upload both the codes in Discord itself by today. You have to decipher this, mono py, and that's how you make your hacking skills. You think hard, you find what's a problem, where you can actually decode it and come in with, you know what, this is the answer. I don't want you to have the right answer. I just want you to have to think hard enough so you get ideas about that. Yeah, do that. Why not? Go for 26 loops. Okay, so that's how you get it done. You get deep, you involve your brain into it, and you figure out something like what? That's the answer. And I want you guys to think about that, because when we talk about real hacking and real scenarios and stuff, then you should be hard enough to actually get to the point where you actually need the answer and solution from. Okay, guys? So find a way to not use 26 loops. How you will do that? Recursion can be used. Is it possible or not? Think about it. So you have limitations, you have solutions, you have problems. Now that's what your brain is used for, to actually think deep inside and come up with an output. Like, you know what? This might be the answer. And that's how you build your activities, your thinking capabilities. Right? Those who don't know what is recursion don't have to use recursion, think from loop. Right, guys? So I think that's all for today. I thought that I might introduce you a good cipher, a next level cipher, which was actually used in World War II. I'll tell you where it used. It was used in World War II in 1854. Right, that's right. So there was a cipher which was used in 1854 in World War. Which one World War it was? Like World War II, maybe. Yeah. World War I, II, I don't know. It was invented in 1854 and was used in World War II. So imagine that much hard cipher was, because it was not able to be deciphered in World War II. We will work on that cipher in the next class itself. I won't reveal it. I guess I might have revealed it, but yeah, I won't. Alright, guys. So best of luck. If you got any doubt, message me on Discord. I will be back on Discord. So message me on Discord. I will give you the answers and everything. Anything you want to come over here. No. That's not it. That's not the one. That's different. No, Harsh, we cannot, because I don't have so much time, man. So time is the big game over here. No, we're not actually trying to decode Enigma over here. Okay, no Enigma decoding. We'll see. Okay. Oh, Tane got the answer. It's Playfair cipher. And it's not that easy to decode. That's fun, guys. Yeah, Tane got the answer, Playfair cipher. That's right. So don't go into that. First of all, let's decode the mono ciphers and then we'll go ahead. So we started from Caesar, the basics one. Then we got more substitution. Then we go to bigger and bigger, and that's how you got to level that these ciphers cannot be decoded. Well, it's way too much decoded. Like, that's not true. Every single cipher can be decoded, but point is, all that ciphers, when you decode it, it requires so much computing power that it's not worth decoding it altogether, right? So it's not like something is impossible in cybersecurity and hacking. It's just that it requires so much programming, so much processing power that it's not worth getting it done. That's why people change password constantly. So we don't know what the answer is, because yeah, brute force can be done every time. Okay. So okay, let me do a fun fact. You know what? You can actually decode, or you can actually find answers from brute force using anything on the world. That's why on big computers and banking systems, the people, those who actually know the output and solutions, 20 in within span of 14 to 15 days, they change the password, and the password is usually about like 25 to 30 digits long, characters long. So 30 characters long password gets changed every. No. They did not use it in 1945. No. What I said was, wait, let me tell you. What I said was that it was started, the cipher was actually generated or being developed or being invented in 1854, right? And they did use it, that cipher, in World War I and II. That's what I said. Okay. The cipher was not used in 1954. It was invented in 1854, which was used later on. That's Vidisha. This is answer for the next class, except not this one. We will talk in the next class. Okay, so Subramaniam, the brute force. What's brute force attacks? Brute force is basically trying every single possible ifs and buts to get the answer. Like this one over here, when we did this, is a brute force attack. Like we got every answer and then we decrypted it. You know what? This is the answer. This is what I was trying to explain to you over here. This was a brute force kind of attack. Okay, so that's what brute force attacks for. We'll answer that in the next class. I guess you got the answer. It was in 1854, and that's how it is. Okay, guys. So that's all for today. What I say? That's all for today. Enjoy your day. Let's have a drum roll and exit the class. Alexa, drum roll, please.
Okay.
Thank you, guys. Bye bye. Tata. See ya. Sayonara.